Okay, so in this lesson, we'll be looking at some more C# basics that we'll be using throughout this course. We learned in the last lesson about variables, operators, and left off on Unity-specific functions such as the start and update function. So we'll be starting this lesson off by learning about how we can create our own functions and how we can use them. Okay, so we can create our own functions by following the same structure that the first two did. So let's make some space in our script to write our function with. Let's start by writing the keyword void, which remember just means that this function won't be producing a specific value from it afterwards, and we'll be using it for own purposes. But again, try not to get confused by that too much. We then need to give it a name, so let's just call it my new function. We then need to add two empty brackets after it, which are parameter brackets. Again, we won't be using them for now. And then we need to add the body, which is used by two curly brackets, just like that. Now make sure that all of your functions start with a capital letter, by the way, or else they won't work and won't be recognized by Unity. Now, unlike the functions we looked at in the last lesson, our own functions don't have any way of being triggered on their own. However, we can trigger them by calling them within another function. So to do this, we simply choose a function we'd like to call it in. For example, I'm going to choose the update function. We then write the name of our function we'd like to trigger within it. So let's write my new function, just like that. And don't forget it's two empty brackets. Finish it with a semicolon, and just like how we reference our variables by name, by referencing our function by name, we'll be able to call it on every frame. So now if we were to put anything inside the myNewFunction function, it would be performed on every frame thanks to the update function. Now what if we wanted to do something within a function, but we only want to do it if a certain condition is met? Let's say hypothetically in our game, only when the player reaches a certain speed, we want to give them a health boost. Well, we can use an if statement by writing the word if with two brackets next to it to do this. So inside the brackets, we want to create our condition, or what we want to check for, which in our case is the speed variable, before we perform a certain behavior, which in our case is to boost the health. Let's say that we want to give the player a health boost when their speed becomes 512. We would then compare whatever value our speed currently is at when this if statement is called by adding two equals operators next to the variable name and then the number 512 after it. Unlike how one equals operator sets the value of a variable, two of them together are known as a type of comparator used to compare one value or one variable to another. So by writing this, we are asking our code to check or compare and see if the speed variable ever becomes equal to 512. Now when it does, I personally want the health to increase by 1. Now I could write health equals health plus 1, but a simpler and a quicker way to increase or decrease an integer variable by 1 is to either add two plus operators or two minus operators respectively following its name. So in our case, I'm going to remove all of this part of our code line and just add two plus signs and the semicolon. Now we can tell that this will happen only when the if statement is called, as our text has indented itself behind the if statement. Let's quickly check to see if this has worked by taking the debug.log command that's checking our health variable, hitting Control X or Command X if you're on a Mac, and then coming down to our myNewFunction space and hitting Control V or Command V on a Mac. And this will simply cut and paste the command into our new function here. We then need to remove this debug.log command just temporarily, as we don't want to clutter up the console tab in Unity with too many commands. We only want to focus on the health one here. We can then save our script with Control S or Command S, jump back into Unity, make sure our console tab is open for us to view, hit play on our scene, and now we need to check to see if our health variable turns from 5 to 10 to 11. So it starts at 10 and reaches 11 as soon as our speed variable hits 512, which remember is being doubled on every frame. Now let's quickly go back to our script, have another look at our double equals comparator, and let's change it as it's not the only one we can use. We can check to see if our value is greater than or even less than by using the same symbols as we would in a maths equation for them. So let's change our statement to check to see when our speed becomes greater than 512 by adding the appropriate symbol for it. If we wanted to, we could combine it with the equals operator to check to see if the speed is either greater than 512 or exactly 512. But for this example, we'll just be using the greater than comparator. I'm also going to be changing our statement so that our debug command is called within the if statement alongside the increase to the health command. Before, we only needed to add the command underneath the if statement because there was only one of them. But now there are two, we'll need to create a body for it with curly brackets to put them in. So to do that, underneath our if statement, let's add two curly brackets. Take both of our commands by hitting Ctrl X or Command X, and then Ctrl V or Command V to paste them in. Just like that. So now that we've done that, let's save our script with Ctrl S or Command S, jump back into Unity, make sure our console tab is nice and clear by hitting the clear button here. Let's play our scene, and now let's see what happens. So once our speed hits above 512, we can see our health variable increase by 1 on every frame. We can also use things called logical operators, which allow us to check for multiple conditions before we run our commands, as well as run them if the opposite of our condition is achieved. The first two are simple ways of saying the words and as well as or in our if statement, but before we create them, I'm going to quickly enable our boolean from the beginning and use that as our second condition. So now we can check to see if either the speed is greater than 512 or the player is grounded boolean is equal to true, which we could do by adding two vertical lines in between the two conditions, like so. What's good about checking booleans in if statements is that we only need to write its name and our code will read that as if it says player is grounded equals true. Now, only one of these conditions has to be true for our player to gain a health boost. However, if we replace the two vertical lines with two ampersand symbols, we're telling our code if speed is greater than 512 and the player is grounded boolean is set to true, then increase the player's health by 1 and show us this in the console tab. So unlike before, where only one condition needed to be true, they now both have to be true for our code to execute our commands. If we wanted to, we could use multiple logical operators to check as many conditions as we wanted to, but for now, I'll leave mine as it is. The other operator we can use is the exclamation mark, and this is to see if a condition is not what we compare it to. So if I put one in front of our boolean, player is grounded, we'll be checking to see if both the speed is greater than 512 and if the player is not on the ground. The last thing we'll talk about when it comes to if statements is how to check for an alternative condition. If we want to, we can follow our if statement with an else if statement. This is our way of saying to our code, if the conditions in the first if statement were not met or didn't happen, then check to see if the conditions in the else if statements are met instead. We could also write following either of those an else statement. An else statement checks to see if the conditions in both the if part and the else if part are ever met, and if they are not, it will do whatever we tell it to under the else statement. Because of this, unlike the if and the else if statements, the else statement doesn't need any brackets as it's checking for conditions already set in our code. So let's test this by changing a few things in our function. I'm first going to remove our boolean variable from the statement just to make things clearer in this example. I'm also going to add health minus semicolon and debug.log health to the else statement. I'm then going to temporarily disable the health ++ line from the if statement. So now when the speed is less than 512, we'll see our health decrease in our console. So now whenever this condition here, speed is greater than 512, is not met, i.e. the speed is less than 512, these two lines will be called and we should see our health display in our console. So let's save our script, go back into Unity, quickly clear our console tab, wait for the script to compile, and we'll play our scene. So now we should see in the console tab that whilst the speed is less than 512, our health will be reduced by 1 on each frame, and then once it reaches 512, it will then stop being reduced. So it starts at 9 and goes all the way down to 0, where the number stops changing. If we stop playing our game and take a look at the console tab, we can see that it starts at 9, is reduced by 1 to 8, reduced by 1 again to 7, and so on until the value reaches 0. Once it reaches 0, our speed has then risen above 512, and the value will stop being reduced. Next, we'll take a look at access modifiers. Now, if we take ourselves right back to the beginning of this script where we talked about our main class, the word public that precedes the rest of our class is an example of an access modifier. They are used to tell other classes within our main class and other scripts what information they can and can't access. So if the word public, for example, is found in front of either a variable, a function, or a class, like at the top of our class here, it allows this information to be accessed by other classes anywhere within Unity. If, for example, we wanted another class in this script, or even a different one from another script, to access the health variable here, we'd write the word public in front of the data type like I've done here. By doing this, we can also view and change the variable within the inspector tab in Unity. The health variable has now become what's called a serialized field. So if I quickly save my script, jump back into Unity and wait for my script to be compiled in the inspector tab, we can see that the health variable has now appeared under the component containing our script and our class and is showing us the value within it. If we needed a lot of public variables to be accessed by other classes but didn't need them all to be serialized, we can go back into our script and above our variable we can write in squared brackets hide in inspector. Now this is an example of what's known as an attribute, a way of adding additional behavior to a variable. They are indicated by the squared brackets and in this case can be really handy for keeping our scripts in Unity organized and clean. If I save my script one more time, jump back into Unity, wait for my script to be compiled, you'll see that even though our variable is still public and still can be accessed by other classes, we can no longer access it in the inspector tab. The next access modifier is private and does the exact opposite of the public modifier. Now any variables, functions or subclasses labeled private cannot be referenced or called upon from another class. Only the class they were created in can use them. This is a great way of protecting functions and variables from being unintentionally used or changed by other classes, and like the public modifier, good for clearly labeling the information in your scripts so you know how they'll be used. Usually, unless we know for a fact that we'll be using something in another class, we label most things private to protect them. Also, if a variable is labeled private, it won't be serialized in the inspector tab, but we can change this by writing another attribute, serialized field, above it. All we need to do is make some space, add some more squared off brackets, and write serialized field. So now if we save our script one more time and jump back into Unity, we can see that even though we set the speed variable to private, we can access it through the inspector tab and change its value thanks to the serialized field attribute. So public and private are the two main access modifiers that we'll be using in this course. There is actually a third called protected, and it works the same way. You simply write the word protected in front of the variable data type. Now we won't be talking about the protected access modifier in this course. However, if you'd like to learn more about it, I'll have a link underneath this lesson for you to follow and find out more. And with that, we're well equipped to start implementing our audio with FMOD. We've now created our own functions, something which comes in very handy for organization. We've also looked at how we can use if statements to only execute an action if a certain condition is met, as well as the difference between the main access modifiers we'll be using in this course. Now we're ready to look at how we can use all of those tools around FMOD event instances, which will be the topic of the next lesson. Just like after the last lesson, feel free to create your own scripts, write your own code, and mess around with the topics we've discussed in today's lesson. See if you can get a feel for them, how you can use them, and what they can and can't do. Thanks again for watching this lesson, and I will see you in the next one.